first question is that examine the continuity of f when f is defined by fx is equal to sin x minus cos x if x not equal to 0 and minus 1 if x is equal to 0. Now here, that is the limit lim limit x tends to 0 fx, because both of them, this condition is given for both the sides. So 0 fx is equal to limit x tends to 0 sin x minus cos x. When x not equal to 0, that means x can be greater than 0 or x can be less than 0 also. So then this is cos x, that is equal to limit x tends to 0 sin 0 minus cos 0. What is that? Cos 0. That is equal to limit, I will just put the value. Sin 0 is how much? It is 0. And cos 0 is 1. We have already studied in class 9. 0 minus 1, that is equal to minus 1. And the limiting value, therefore function value or limiting value, the limit, this is fx is equal to, functional value is equal to minus 1 when x is equal to 0. Therefore, limit x tends to 0 fx is equal to f of 0 implies minus 1 is equal to minus 1. This is given implies the function f is continuous at x is equal to 0, because the functional value and the limiting value, they are the same. Okay, and let me explain it once again. Okay, examine the continuity of the functions, that is fx is equal to sin x minus cos x, and if x not equal to 0, that means it is the left hand side and right hand side limits. Then it is minus 1 if x is equal to 0, that is the functional value. Okay, now limit x tends to 0 fx is equal to limit x tends to 0 fx is equal to what we get, that is sin x minus cos x, that is sin 0 limit x tends to 0, and when I put the value of that, I will just put it is sin 0 minus cos 0, that is 0 minus 1, that is minus 1, and f of 0, that is this is minus 1 when x is equal to 0. Therefore, limit fx is equal to f of 0, that is minus 1 is equal to minus 1, this is given. Therefore, the function f is continuous at x is equal to 0. Question number 2. Find the value of k so that the function f is continuous at x is equal to pi by 2, where fx is equal to k cos x and divided by pi minus 2x when x is not equal to pi by 2, and it is 3 when x is equal to pi by 2. So limit sums we have done in class 11. So changing the limit, changing the intervals, so we have learned. So we will write solution. Let x pi by 2 minus x is equal to y. Yes, here as x tends to pi by 2, y tends to 0, 0. So I will be changing this. Therefore, limit y tends to 0. Y tends to 0. F of y is equal to f of y is equal to k cos pi by 2 minus x pi by 2 minus y k divided by pi minus 2 into pi by 2 minus y. I am just putting the value of x when y not equal to 0. Okay, implies f of y limit y tends to 0. Here limit y tends to 0 f of y, it is that therefore limit y tends to 0, y tends to 0. This is k sin y, because cos x minus y is sin y, cos x minus y is sin y, divided by, that is, this is pi minus pi and plus of 2y, plus of 2y. Okay, and f of now f of pi by that is f here, f of pi by 2, f of y is equal to 3, when here also it will remain like that when y is equal to 0. So okay, therefore the function is continuous when limit y tends to 0, y tends to 0, f of y is equal to f of y at f of 0. Now f of 0, it remains that it remains 3 only, there is no change. So now it is, that is equal to, implies how much, that is here k sin y by y is how much, that is sin y by y is 1, k by 2 is equal to 3, therefore k is equal to 6. Since the identity we have used, sin y by y is equal to 1, limit y tends to 0. This is the identity we have used, and here k is equal to 6. Have you followed, all of you? First we have to change the intervals. We have to change the intervals because otherwise we find it difficult to solve. It will be for, it's a hodgepodge of being solved. Okay, so start. Now examine the continuity of f when f is defined by fx is equal to kx plus 1 when x is less than or equal to pi, or cos x when it is x is greater than pi. So I will find out left hand limit. Left hand limit is equal to, therefore the left hand limit is equal to, this is limit x tends to pi k cos x pi x plus of 1. Instead of x, I will just put it, that is k pi plus of 1, and limit, right hand limit will be limit x tends to, right hand limit is pi plus fx is equal to limit x tends to pi cos x, that is equal to cos of pi that is equal to, cos pi is how much? Cos pi is how much? Minus 1. Cos pi is minus 1. Therefore, and f of pi will be, that is here, f of pi comes here, the equal sign, that is k pi plus of 1. It is the same thing we have got. Okay. Therefore, k pi plus of 1 is equal to minus of 1. Therefore, k pi is equal to minus of 2. Therefore, k is equal to minus 2 pi. So, the answer is k is equal to minus 2 by pi. Have you followed? So, this is the end of the sum. Here, examine the continuity of function f when f is defined by, that is fx is equal to kx plus 1 when x is less than or equal to pi, cos x when x is greater than pi. Here functional value, can you tell me what is the functional value? When it is equal to. Equal to means cos of pi, that is k pi plus of 1. So I have just find out. I think all of you have understood it, and now you are thorough with this type of sums.